Here we are in week 4 as we look at the topic of data-driven decision making and how it relates to data analysis. First of all, we want to talk a little bit about what's addressed in chapter 6 from some different perspectives. And we ask ourselves is where might we find data that we could use to evaluate the programs that we're a part of, or to evaluate a decision that needs to be made. First of all, we can have tabulated raw data, and this is where we just take a list of actual numbers such as church attendance, offerings given, scores by students, and we merely take these scores, we put them in a table, and we can add them up. We can average them, we can get the standard deviation, we can get the average or the mean, so on and so forth. I think this is fairly straightforward, and you're probably most familiar with this. The second kind of data source that we can draw from is that of calculated ratios. In other words, we just don't ask how many adults we have or how many children we have in our church, but we look for the ratio of the combination of two numbers. This is often used in the business world in what's called common sizing. But in this feature, we take two numbers and we take the ratio of the two. So we might take the ratio of children in our entire church. So we take the whole congregation and we see what percentage or what ratio we have of children. So we might say that for every 4 people we have in our church, 1 of them is a child. Or for adults, we might say if for every 4 people in our church, there are 2 adults. That would mean for every 100 people in our church, there would be 50 adults. So ratios are very powerful because they can give us a more common understanding. Let me give you an example from a church. We might have a church where they have 1 child for every 5 adults. There might be another church where there's 1 child for every 10 adults. So this ratio would demonstrate different characteristics of these groups and help us to get a greater clarity of understanding for this, regardless of whether the church overall has 200 people or 2,000 people. We can take data from a population. A population is the entire group of people or the entire set of data for the group of people that we're looking at. So we could take the age of every person in a church and average that. We could take the age of everyone in the church and put that across the normal distribution and see how that compares to other churches. Or sometimes we just take that data from a sample. So we don't go out and ask the average age of everyone in your city, but we might, like Gallup, go out and ask 1,000 people what their average age is. And by taking this sample, we can predict what the population average might be with a fair amount of accuracy. The fifth item that I have here is data over time, and this is where we compare what we are doing presently compared to some past time. So we could take last year's giving over this year's giving, last year's attendance over this year's attendance. We could take last year's test scores for our students and this year's test scores, or last week's test scores and this week's test scores. So this just gives you a sample of the data sources that you might be able to draw from. When you look in your book, you'll see even a broader selection and a broader discussion of this that we haven't touched on here, particularly as it relates to quantitative data that we've largely looked at here, or that of qualitative data sources that are found more from narrative examples. Sometimes we go back, as the book said, and look at historical data from past years, or sometimes we go out and collect new data. So there's many ways in which you can draw data, and here are a few examples as well as those listed in your book. When we come to data analysis, first of all, I wanted to mention some of the possible tools that we could use. We could use a calculator where we just take number after number and average them together or multiply them together, or whatever analysis we want to do with a simple calculator. In these days, the most common tool we often use is Microsoft Excel, which is a spreadsheet which has so many analytical tools built in, it allows our work to be done more quickly and more accurately. if you're looking for a tutorial on using Microsoft Excel for data analysis to find the mean, the median, or other analytical indices such as standard deviation or variance, Microsoft Excel can do all these. For some more powerful analysis, we'll use full-blown statistical packages such as SAS or SPSS. These used to be just used on mainframes, but now they can be used on a desktop or a notebook computer. But these tools are increasingly powerful. They can give us all kinds of information from the data that we feed into it. First of all, I want to talk about descriptive statistics, and this is where we would come in and describe a sample or a population. Could be how old a group is by average. Could be how tall a group is, and we can understand what the mean or the median or the mode are. These are things that would help us just to understand the nature of the population or sample which we have drawn. The third bullet that we have there is that of data trends. In other words, we could say that over a number of samplings, we can see a trend in a certain direction. So we could take the attendance at our church every month and see certain trends. We could take the attendance every year and see certain trends. So rather than just having one point in time, we can look across data samplings and across periods of time and see trends of analysis that give us greater insight. One thing that's often overlooked by people is that of data variability. Let me give you an example. You might have 5 students in a class and their average height is 6 feet tall. But that means that you have 2 students who are 6 feet tall. You have 1 student who's 6 feet tall, 2 students who are 5 feet tall, and 2 students who are 7 feet tall, and on average they're 6 feet tall. This group has quite a bit of variability, having students who are 5 feet tall, 6 feet tall, and 7 feet tall. You could also have a group of 5 students who have an average height of 6 feet, and they could all be exactly 6 feet high. So just the descriptive statistic of the mean or the average height doesn't necessarily show the variability of that height. So you could have an average height of one group without much variability. You could have another group which the average height has a lot of variability. And this is often described by the standard deviation which Excel can calculate for you. Eventually we want to get to the aspect of what does the data tell you. It tells us things about our organization. It tells about where we're at in comparison to our goals. It tells us where we're at from where we used to be to where we want to be now. So we can have trends, we can have outcomes, we can have benchmarks, we can have thresholds. And at the end of the day, we're looking at our data to help us understand more clearly the effectiveness of what we're about. Lastly, I want to highlight 2 things, and that's, first of all, I want you to be curious with your data. Look at it from all different kinds of angles and think through, what is the data telling us about our sample? What's the data telling us about our programs? What's the data telling us about our effectiveness? But lastly, we also want you to be cautious, and that means that we don't want you to draw assumptions that are too vague. For example, you might find some slight differences over a group this year from last year. Be cautious about making too much of those small differences. Maybe the variability has made this happen just by random chance. So as you look at your data, ask yourself what the data tells you. Be curious about what you can find out from the data. Maybe there's more variability than you thought. What does that tell you about your situation? Maybe the numbers are higher or lower than you might have thought. Why is that? But also be cautious and not reading too much into the data, because this could lead you astray in making false claims that maybe just happened by randomness.